Hey guys, now that we know how to make these IFE diagrams, let's use them to solve some gas law problems. So we're going to see similar situations where we have some variables amongst pressure, volume, number of gas particles, or temperature change, and then we want to know how that change affects everything else. So here's a problem that hopefully looks familiar. A sample of gas under 97.6 kilopascals of pressure is heated from 294 kelvins to 350 kelvins. Find the new pressure. So the first thing we're going to do is, since we have a gas with these variables changing, we're going to construct our IFE chart. So remember, I means the initial, F means final, and effect means change. And we're going to set it up to look at pressure, volume, number of gas particles, and temperature. So our initial pressure before the change, before we heated this particular gas, our initial pressure was 97.6. Volume we don't know about, number of particles we don't know about, but the temperature was 294. After the change, we don't know what the pressure was. Notice that's what we're supposed to find. Find the new pressure. So we want the final pressure. That's what we're looking for. Volume didn't change. Number of particles didn't change. Temperature sure did, though. Went to 350. And now we need to look at the effect of this. For the variables that stayed constant, that didn't change, we don't have to worry about it. For those that did, we know that temperature went up. And since temperature is directly proportional to pressure, we know that the pressure is going to go up as well. So we don't know anything yet except that the pressure should go up. We don't know by how much. We don't know what the result of this is going to be other than the pressure goes up. Here's how we find out by how much it's going to go up or down. We know the initial pressure is 97.6. So we just write that down. And now what we're going to do is we're going to multiply by one of these and divide by the other one. Another way of saying this is that we're going to make a fraction using these two values. So one of these will go in the top, one of these will go in the bottom of this fraction. And here's the way it works. If this gets bigger, the bigger value goes on top. If this gets smaller, the smaller value goes on top. So this is getting bigger, so we want our bigger value on top. 350, and our smaller value, 294, on bottom. The reason being is that this fraction really just means take 97.6, multiply it by whatever's on top, and then divide all of that by whatever's on bottom. That's really all a fraction means. And so in this case, we're multiplying by the big one and dividing by the small one. If this pressure were to go down, then we would want to multiply by the small one and divide by the big one. But in this case, we take 97.6 times 350 divided by 294. And this is a job for a calculator, no doubt. And the answer I get is 116.19. And this is a pressure, so that's going to be kilopascals. So my new pressure is 116 kilopascals. Now notice this makes sense. We said the pressure was going to go up. It was 97.6. So it would make sense that it would go up to 116.19. So again, to recap how we did this, we took the initial value for the pressure and we multiplied it by some fraction. If the pressure was supposed to get bigger, we put the bigger number on top. If this was supposed to get smaller, the bigger number should go on the bottom. And then all we did was do the math here. 97.6 times 350, get your answer, and then divide that by 294. So we'll look at another one of these to make sure we know what we're doing. All right, now we have another problem. A balloon under 101 kilopascals of pressure is dipped into liquid nitrogen at a temperature of 77 Kelvin. Really cold. If the room temperature was 290 Kelvin, find the new pressure. So again, we have to do an IFE chart. And I'll move this up to the top. Notice that rather than write out the entire word, you are welcome to just abbreviate IFE so long as you know what all those mean. And with our chart constructed, we can now go to town on listing all of these. So the balloon's under 101 kilopascals of pressure before it's dipped into the liquid nitrogen. So we know our pressure, our initial pressure, was 101. We're not told about the initial volume or the initial number of particles, but we are told the initial temperature, and be careful here, you must read carefully. The balloon is dipped into liquid nitrogen at a temperature of 77 Kelvin. Room temperature was 290 Kelvin. Stop and think for a second about which one came first. It was in the room first. The initial temperature is 290 Kelvin. So now let's talk about the final after the change. We don't know about the pressure, volume, and number of particles stayed the same, and the new temperature is now 77 Kelvin. And now we can start looking at the effect of all this. Volume and number of particles are easy. Temperature went down. So what does this mean for pressure? Ask yourself this. Think of the answer before I show it to you here. If temperature goes down, and across this line, everything is directly proportional. So temperature is directly proportional to pressure, which means the pressure is going to go down as well. So whatever our new pressure is, we're expecting it to be less than 101 kilopascals. Now, to find out just how much less, we take the value that we're wanting to investigate and we write down the initial. So the initial pressure was 101. And now we're going to make a fraction out of the one that we know. Now remember, this pressure is wanting to get smaller, so we look for the bigger number, and that's got to go on bottom, 290. This means that when we multiply by this fraction, if the bigger number is on bottom, this number is going to get smaller, which is what we expect. And huzzah for calculators. Now we just have to figure this up. So step by step, what I'm doing here is I'm taking 101 and I'm going to multiply that by 77. And that gets me this value, lucky sevens. So now that I've multiplied these two, now I'm going to divide this number by 290. And this gives me my new pressure, 26.82, and this is a pressure. Our units were given in kilopascals, so this is still kilopascals. So our pressure went from 101 kilopascals to 26.82. Notice this jives with our chart. The pressure was supposed to drop, and indeed it did, so we can confirm that this is in fact the correct answer.